tomorrow. So this is the last chance we get. Gentle reminder, this class does require active involvement. So as you watch this lecture or you take the video, make sure you're taking notes, okay? Reflective journal, title it, Chapter 2 Test Review, okay? Chapter 2 Test Review. Make sure you're actively involved so you can prepare yourself best for the Chapter 2 test. A little bit of background before we get into the math. Reasoning and proofs started 1,720 years ago during the era of Greek philosophers. So a lot of these questions are critical thinking, finding patterns. They're not overtly a math question like 2 plus 2. Is that clear?
Yes.
Gentle note, these people would sit in a room for months at a time arguing, and at the end of a 1 month long debate, they would stand up and say, after our 1 month debate, we've concluded that we know nothing. And then everyone would applaud because they were excited that they debated for a month. Would you guys feel like that was a waste of time?
Amen.
Talking for a month and then saying at the end you don't know if anything is true?
Yeah.
That's how these people roll though, okay? So you gotta get into their worlds if you're gonna be successful. So again, make sure you're imagining and asking why. This is chapter 2, baby, come on. Anyways, so critical thinking, again, finding the pattern. Here we have a base of 1. Here we have a base of 2. Here we have a base of 3. What's the next one going to be?
4.
A base of 4. So that is going to be C. So again, it might be difficult to take notes on a question like this. That's fine. Do it however you need to. Whatever empowers you to see the sequence, to see the pattern. Now this question wasn't that tough, but I still had 22 out of my 105 get it wrong. 22 students did not see the pattern. For this one, out of 105, it was 96 students that got this wrong. 96 students got this wrong, and Mr. Rivera gave absolutely 0 hints. Why? Because I'm here to help you now. Find the sum of the next 3 terms of the arithmetic sequence. So we're looking for the next 3 terms of the arithmetic sequence. Every single time, what's happening to the sequence? What's the rule? Going up by 5. Excellent. So that means we're looking for the next 3 terms by adding 5. So what's the next term, class? 28. What's after that? 33. And after 33? 38. Great. So we have our next 3 terms. After you guys find those out, you're trying to put them into little squares, aren't you? This is what you guys wanted to do, right? 28, 33, and 38. Is that what you were trying to fit?
Yes.
But you'll see, is this spot a number spot or a plus or minus spot? This is a plus or minus spot, which means you can only put the positive or a negative symbol, mainly just the negative if it's a negative answer. Does that help you out? No, it makes it impossible to fit the numbers with the space. So then maybe you had to do this and now you're confused and you're frustrated, right? So at this point you've hit a dead end, right? You hit a dead end? You're not sure what to do next? Great. So you're not sure what to do next? Here's the deal, right? You can either give up or you can try again. Well, many of you decided to raise your hand and ask me a question, and I said good luck. Did I help out at all? No. So now you guys are thinking, dang, I'm really going to have to give up now because I don't know what to do next. The only hint was to read the directions. Did you guys do that? No? Maybe? Let's read the directions again. Are we ready? So we've hit a dead end, Elvin. We're frustrated. We don't know what to do. Let's see if the directions help. Okay, Elvin? Look at this. Find the sum. Again, find the sum. Again, find the sum. Find the sum. Find the sum. What does it mean to find the sum?
The total.
The total. You had to add all 3 numbers together, which means when you add them all together, you get 99. So you guys did great finding the next 3 terms of the arithmetic sequence, but you did not complete the question and find the sum of the next 3 terms. Do you see how that's a little tricky? Right? You have to imagine, you have to wonder why. Victoria, did you remember the great words of Ariana Grande? Sorry, Doja Cat. Did you ask why? Did you imagine? And you struggled with this question, didn't you? please open up that brain for critical thinking. You guys are geniuses, you need to unlock it, yes?
I'm sure I got that question right.
Well, I'm very proud of you. Congratulations. You were one of 9 students. With that being said, do we see how this is answered now? Any questions? Great. Let's go ahead and look at number 16. How many assumptions are we allowed to make in geometry? 0 assumptions. So we can't really assume, but we can identify what is true. Identify what is true and what is not true. So let's identify. Here we have angle DBG. DBG. Is that 90 degrees?
No.
Not only does it not look 90 degrees, but there's no perpendicular marker. If it was 90 degrees, you would see something like that. Do we see that? No, we don't see that. Do we see a sign that says anywhere pointing to it 90 degrees? So we can't identify. The last one, did you see that in the directions it told you that 2 lines were perpendicular? Again, an upside down T looking like this, line D and line G. Did you see this anywhere? Saying that they're perpendicular? No. So do you know that they're 90? No. And if you said yes, you were assuming, which you cannot assume. Just because it looks kind of like it might be 90, you didn't see a perpendicular marker and you weren't told that they were perpendicular. Alana and Ethan, why are 2 people trying to go to the bathroom at once?
I'm sitting down.
Okay, great. Bye, Alana.
My name on this tree.
Okay. So again, the answer was no. Can you please move that? Because I'm going to step on it the rest of the day. Just move spot. Just go this way. If you don't mind me stepping on your slides, that's fine.
Just stay in one spot.
I'm literally incapable of doing that. Okay? It's a us problem because I'm still stepping on it. DBG, okay? Sorry, DBC. Are D, B, and C coplanar? So here we have D, here we have B, and here we have C. What does coplanar mean? On the same plane. Are C, B, and D on the same plane? Yes, they are. Again, they are literally, D, B, and C are on the same green plane. Yes. So again, D, B, and C, they are on the same plane. So we have identified them as coplanar. Capiche? Coplanar, again, on the same plane. Next we have number 18. Number 18 was it was a 50-50. There was 64 students that did not get this right. This one is a rather easy one, only if we use our critical thinking. P, W, and Q. So go ahead and on your paper, draw P and W and Q. You are told that PW and QW, again, line segment PW, is congruent to line segment QW. So that means the space from here to here and the space from here to here is exactly the same. How would you mark that? How would you mark that? You can use 1 tick. That's a congruency marker, right? That means that PW is congruent to WQ. However, when you put your ticks here, you'll find that something is really, really, really wrong with the diagram. What is it?
There's 4 congruent.
Yes. Because you put 1 tick mark here, it's saying that there's 4 congruent line segments. Because 1, 2, 3, 4 different line segments have the same tick mark. And it's saying that PW is the same as WQ, which is fine, but PW is also the same thing as TW. Is this length the same one as this small one?
No.
So are they different?
Uh-huh.
Yes. So you cannot use the same congruency marker. You'll have to use a different one, which just would look like this. Do you see that? So because these have 1, they're in the same club, and because these have 2, they're in the same club. So you would have to do 2 lines, 2 tick marks, because the 1 was already taken for a much shorter line. Does that make sense, Elvin? Yes? So the answer is put double tick marks on each line segment. Because the single tick marks is already being taken by a much shorter line segment. So yes, this is critical thinking / diagrams. Yeah, go back for a moment. Trenton, feel free to take notes on this because you'll be retaking the chapter 2 practice test that you just submitted again for a grade this time. All of the, did you submit it? Great, these are the answers to all the questions you just finished, okay? You can also watch the beginning of the video on Canvas. Okay, let's go ahead and move on. Which property is demonstrated below? If the measure of angle 1 is equal to the measure of angle 2, then the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Now, if and then, which one's the hypothesis? If, thank you. And the conclusion? Then, great. Now, we have to think critically. Here we have the hypothesis, here we have the conclusion. This might look algebra, but it's not, it's purely geometry. Think to yourself, what is in the hypothesis and what is in the conclusion? Now think to yourself, what is in the conclusion that was not there previously in the hypothesis? What do you see in this equation that wasn't there before? What do we see? What was in this equation that wasn't there before? The measure of angle 3. We see it here and we see it here. But is that all that we see, or is there something else that wasn't there before?
Addition.
The addition symbol. So they are adding the measure of angle 3 to both sides. Again, they're adding the measure of angle 3 on the left side and the measure of angle 3 on the right. What property of equality adds something to both sides? Again, what property of equality adds to both sides? Again, what property of equality uses addition to add something to both sides?
It's obviously addition.
That is obviously the addition, right? So yes, this is our addition property of equality. Any questions? Let's go ahead and do another justification. So here we have 3x equals 21. Again, 3x equals 21. That 3x, is that add, subtract, multiply, divide? What's going on? Yes, but right now, Renzo, what's currently happening? Multiplying, right? And what's the opposite of multiplying by 3? Division. So dividing by 3. You're going to divide both sides by 3. 3 divided by 3 is 1, so you have 1x equals 7. And we don't need that 1, so it's just x equals 7. And Renzo, what property of equality was that?
Division property.
Yes, the division property. Now, be careful, because if you use mental math and you're just looking at it initially, a lot of students answer the multiplication property because they see 3 times x and they know that's multiplication. But you do not use the multiplication property of equality to solve this problem. You have to do the opposite of multiplying by 3, which is divide, to cancel it out. Is that clear? So please make sure you're not falling for the trap and just answering multiplication property, because that would be incorrect. The property that you use is the division property of equality. Any questions? Great. Next question gets a little bit trickier. So, the perimeter is equal to radius times theta plus 2. They want you to rewrite the perimeter formula in terms of theta. There's a lot going on here. First and foremost, I would encourage you, this is a geometry class, so this is a geometry question. You're not solving some wacky formula. I also want to encourage you, Mr. Rivera loves these problems. I love them. Do you know who else loves them? The people who write your benchmarks. So you're not going to see 10 of them, but you will see at least one, okay? Is this an algebra problem or geometry problem, class? It's a geometry problem, so let's look at the geometry of it. First and foremost, in terms of theta. We're solving in terms of theta. Theta is a Greek letter. Any letter in a formula or equation is a what? A variable, yes. So theta is a variable. Do we feel comfortable using theta, or should we replace theta with x? What do you guys want to do? You want to keep using theta? Or you want to use x? Theta? Okay, we'll solve with theta then.
It's called theta?
Theta, yes. So what you're going to want to do is you're going to rewrite the formula. The perimeter is equal to the radius times theta plus 2. And you want to solve for theta. Just like you would solve for x, you're going to solve for theta. So you're going to do the opposite and get theta all by itself on one side of the equal sign. What is farther away from theta? Plus 2 or times r? Times r. In fact, r is so far away from theta that it's separated by a parentheses. Do you see that? Great, so we're going to start. What's the opposite of multiplying by r? Dividing by r. Just one side or both? Both. So we're going to divide by r. We're going to divide by r. Great. So we have p divided by r, we just leave it like that, is equal to r divided by r. What's r divided by r?
R.
Close. Okay, let's look at this.
R1.
Yes, close. There's 10 people and there's 10 pizzas. Each gets what? 1. What's 5 divided by 5? So any number divided by itself is always 1. So r divided by r is going to be 1, which just means that r divided by r cancels out and we don't need to rewrite it because it becomes 1. So we have theta plus 2. Theta plus 2. What are we going to do next? How do we get theta all by itself? No. We want theta alone. What needs to go away?
2.
The plus 2. What's the opposite of adding 2? Yeah, so we just subtract 2 from both sides. We subtract 2 from both sides. This cancels out. And we get theta is equal to, I'm going to write this over here, p divided by r minus 2. Again, p divided by r minus 2. Now, even though initially this looks really complicated, I want to encourage you to always try, because you were able to solve this question doing 2 properties of equality. First, the division property of equality, and then the subtraction property of equality. By simply dividing and then subtracting, you were able to solve and rewrite a new formula. Does that make sense? So this question will come back simply because it's a geometry question, and using 2 or 3 properties of equality to solve something isn't that complicated. The only thing that's complicated is that you see terms that you've never seen before. But if I were to make this an x, and I were to make this an 8, we would all be able to get that right, wouldn't we? Okay? So please don't be scared by the variables. Okay. This one is everyone's favorite. So we're going to start a 2-column proof. So we have our statements on the left and our reasons on the right. The first statement was the measure of angle ABE equals the measure of CBD. That is the what? What's the reason for that? The first one is always A. The first reason is always the, yes, we just write given. Number 2 and number 3 are both definitions. They define something. A definition is just something that you can identify just like we identified based on the diagram, okay? So this is a definition, you just define them to be equal to each other. Here we have the measure of ABE. And then we're told that ABE is equal to this, isn't it? Do you see that? Do you see that, yes or no? Again, measure of ABE, and we're told ABE is equal to the measure of ABD plus the measure of DBE. So what we can do is we can take this out of the equation, and we can insert or substitute this in here. And that's what happens with number 4. Again, ABD plus DBE, ABD plus DBE. Then, they took the second term, CBD. Do you see that right here? They tell you right here that CBD is equal to CBE plus DBE. So what they did is they took this out of the formula and they instead inserted this in here. Do you see how they did that? So the original one was this small one equals this small one. The new formula was they inserted what was equal to the first thing in here and what was equal to the second thing in here. And that's using substitution. I'm not saying that I like this and I'm not saying that it's easy, but I'm saying the answer was substitution. When a substitute teacher comes in, what does it do? It replaces me or the teacher for a little bit, right? So because they use definitions to replace something new into the formula, it's substitution. Okay? What is the next thing that happens? Again, what is in number 5 that wasn't in number 4? What do you see that's new?
A minus sign?
The minus sign, great. They're subtracting DBE from just one side or both?
Both.
Both. So what property of equality subtracts things from both sides?
Substitution. Oh shit. Division.
Class, let's help him out. He did great. What property subtracts things from both sides?
Subtraction.
The subtraction property of equality. You said substitution.
I thought I said subtraction.
Subtraction property.
What time is it by any chance?
That should be a denture hint. So, substitution. Now, being very frank, Mr. Rivera loves to be honest. If you get this question wrong on the benchmark, I won't even care, right? I'll be like, you tried your best and that's what matters. And I'll smile, okay? Because 2-column proofs, justifications, it's a lot, isn't it? We'll get there. However, this next portion, I don't want to see anyone getting this wrong. I have 0 tolerance for this one getting wrong because we've been talking about this one since day 1. So we have to identify what can we make a mistake on and what do we have to earn to get a good grade. This is a have to win. Does that make sense? You get all the proof questions wrong, you're still going to get a 3, 4, 5 as long as you make sure to get these right. Is that clear? Great, so this is what we got to win. Victoria, complementary, what does that mean to you? Not sure? Great, then we're going to review it. Danny, what does it mean to you? Goes together. We need a little bit more, but you're on the right track. Complementary is equal to how many degrees?
90.
That's correct. Again, complementary turns into a 9, and then we make it 90. So when 2 angles are complementary, Victoria, when 2 angles are complementary, Danny, they need to add up to 90, okay? So here we have 3 is equal to 19, and we want to find out what 4 is equal to. 90 minus 19, we regroup minus 1 plus 10. We get 71. Okay? So again, number 12 is 71. Any questions? This one is a need to win one. Here is another need to win. So we have 10 minutes left of class. We have 4 more questions. We're going to take notes on these 4 questions. and then you will be dismissed, okay? We're almost done. Let's go ahead and take notes on this final stretch. Go ahead and copy the diagram on your notes. The diagram looks like this. And angle 2, is 59. Okay? Two intersecting lines. There are two types of relationships that Mr. Rivera always is talking about. You've taken notes on these before, but they're still not drilled into your head, so please take notes one more time. What are the types of angle relationships that we see right now? There are two of them. Do we remember any of them? Vertical, yes. Vertical what? Excellent, Brian. I'm obsessed with your answer. Vertical angles, thank you. Vertical angles. So, vertical angles, they're always opposite to each other. AKA, because they're opposite, they are identical, so they're congruent, okay? Congruent means that they are the same. So, do we see angle 2? What is opposite to angle 2?
Angle 4.
Angle 4. So that means that angle 2 and angle 4, angle 2 and angle 4 are vertical angles. What about angle 1? What's the vertical angle for angle 1? What's the opposite to angle 1? Angle 3. So here are your two vertical angle pairs. What is the other type of relationship that we can see? Starts with L. Linear pair, yes. Linear pair. Linear pairs are side-by-side angles, side by side, same side of a line. And because they are the same side of a line, that means that they are equal to 180 degrees, which means that they're supplementary, complementary, what are they? Supplementary, because they're 180. Supplementary. Thank you, Donjay. Great. We have quite a lot of linear pairs. Again, we're looking for anything the same side of a line. Are 1 and 2 the same side of a line? Alana,
Yeah.
are 1 and 2 on the same side of that line?
Yeah.
Yes, so that means that 1 and 2 are a linear pair. Are 2 and 3 the same side of this line? They're the same side of this line? Do they add up to 180? Yes. So 2 and 3 are linear pairs. What about 3 and 4? Are 3 and 4 side by side, same side of a line? Yep, 3 and 4 are also linear pair. And 4 and 1, are 4 and 1 the same side of that line? Yes. Again, class, vertical angles and linear pairs, this is literally the building block, the most important, the foundation for chapter 3. So chapter 3, which is starting very soon, will take this information and use it every single day. Okay? So please don't forget, we'll be talking about it quite often. Again, angle 2 is 59. What is automatically 59 then?
Angle.
4, the opposite angle, the vertical angle, yes. 59. How do we figure out 1? Yeah? Yeah, so you would do 180 minus 59 because they both have to add up to 59. So you get 121. If angle 1 is 121, what else is automatically 121? Number 3, 121. So, using vertical angles, whatever's opposite of it, the same, and then you would just use 180 minus whatever because they're supplementary. If it was complementary, you would use 90, but these are supplementary. Any questions on this? No? Perfect. Then go ahead and do the same thing again with a different angle measure. So these notes are still good because the numbers are still in the same spots, but we have 88 now. So the measured angle 4 is 88. What are the other ones? Keep going, candidates, you'll see colorful holidays. You're tracking to custom line. Whatever you got wrong, you're supposed to be So yes, if 1's 88, if 4 is 88, then 2 is 88. 180 minus 88 is going to be 92. So we have 2 more questions, and you don't have to write anything down, but just go ahead and look to make sure we're on the same page. Angle 3 and angle 4 are vertical angles. If angle 4 is 11.5, what is angle 3?
Today is We Stand for Safety campaign lesson on what to do
Again.
if you see or hear a threat. Take action. By doing so, you will be
Congruent,
standing for safety and
the
ensuring
same.
that schools remain a safe place for everyone. Hope everyone has a great afternoon and dismissal. Wait for the bell, but pride never does.